Alright guys, this is your Unit 13 Part A review, just on the first 4 days of material. I'm just going to go through the review. So, here we go, starting from the beginning. We've got a two-way table of students spotted skiing at Holiday Valley. You've got them wearing goggles or no goggles, helmet or no helmet, and they've figured out the probabilities for us in the middle of the table. We want to find the probability that we select a skier with goggles on that is not wearing a helmet. So the first part here is your given, essentially. You're looking at the probability of grabbing a skier with goggles on. So that means I'm only going to look at this row. And of those with goggles, they're not wearing a helmet. So no helmet. So we do 0.12 divided by probability that they are wearing goggles is 0.57. Okay, so in your calculator, we divide these. Okay, so 3 or 4 decimals is sufficient. I'll just do 3, but you can do 4 for statistics. Oh, and in this case, it says round all answers to the nearest thousands. So that's a good indicator to do 3 decimals. Okay, so 0.211. What is the probability that a skier without a helmet has goggles on? So again, this is your given. You're looking for the people without a helmet on. So let me erase this real quick. So without a helmet, we're looking here. And of those without a helmet, they have goggles on. So 0.12 divided by 0.45. Grab my calculator. Oh my goodness. Oh my goodness. Okay, so 0.267. Determine whether wearing goggles is independent from wearing a helmet. Show your calculations to support your answer, then provide a summary sentence in the context of the problem. So doing our calculations in the way that they present it. So wearing goggles is what I'll calculate first. Probability of them just wearing goggles is 0.57. Probability of them wearing goggles given they're wearing a helmet means I'm only looking at the helmets and the ones that are wearing goggles. So 0.45 divided by 0.55. Okay, so I divide those. .818. Okay, now if they were independent, I would have the same exact decimal answer for these. The way I always think about it is you have this first calculation, which is kind of like your baseline, so probability of goggles, and then I add in this extra information of wearing a helmet. If it didn't change, that meant that the second event had no bearing on the other event. So adding the extra information really didn't make a difference. But because I added in this whole given they're wearing a helmet, it made a difference in the probability. Therefore, these events are not independent. Okay, so as far as likelihood goes here is what they're looking for with the in the context. From our baseline, essentially, I had 0.57. My new calculation was 0.81 up, or 818, which means the probability increased. So what that means is you are more likely to be wearing goggles given you're wearing a helmet. So as long as you read this given line exactly how the notation reads it, you should be answering this fine. I got more likely from the fact that this probability increased from the 0.57. If it had decreased, I would have said less likely. All right, so here's question 2 on the packet. A newspaper did a survey of adults and found that 54% of the population as a whole favored stricter gun laws. Okay, so 54% of a hypothetical 1,000 is in favor of stricter gun laws, so 540. They broke down the results along gender lines and found that 65% of those in favor of stricter laws are women. So it's 65% of this 540. So 0.65 of 540 is 351. Which means that this number must be 189 in order for this to all add up to 540. Now, this sentence I reworked a little bit from the packet, so just be aware. If 35% of the remaining adults who are against stricter gun control, so that would be all of these guys, are female, fill in the two-way table and answer the questions below. So if 540 of our adults are here, that means that 460 must be against the stricter gun control laws. Of those who are against stricter gun control, 35% of those adults are going to be female. So I'll do 0.35 of the 460, and that's what gives me 161. Which means then that this cell up here must be 299 in order for everything to add up to 460. Across this way, this is 488. Across this way, this is 512. And everything adds to 1,000. If a person was selected at random, are the events being a woman and being in favor of stricter gun laws dependent or independent? Okay, so we need to figure out the probability of being female and the probability of female given they're in favor of strict gun laws or in favor of gun control. I'll write it like that. Okay, so just being female, it looks like we have 161 out of, female looks like we have 512 out of our 1,000. Okay, so 0.512 then is the probability. Females given they're in favor of control. Yeah, I really should write this as in favor of gun control is 540 of them total. 350 of one of them are female. Okay, and then if I divide those, I would get 0.65, and these are not equal. Therefore, these are not independent. And this is because, according to my work here, you are more likely to be a female given you're in favor of stricter gun control. Okay, A is considered probability of a male, B is considered against gun control. Find the probability of A and B. So male and against gun control was 299 out of 1,000, which is 0.299. Probability of male or against gun control is the probability of A plus the probability of B, take away any overlap. So that's their intersection. So probability of just being male was 540 out of 1,000, plus the probability of being against gun control, so that's 460. Wait a minute, I did this wrong. Probability of male, excuse me, was 488. There's 488 males. Whoopsies. So 488 out of 1,000. Okay. Plus being against was 460 out of 1,000. Take away the intersection of male and against. So that's 299. Okay, so add, subtract the numerators. I get 649 out of 1,000, which is 0.649. The results of a poll of 200 students are shown in the table. For this group of students, do the data suggest that gender and preferred music styles are independent of one another? Justify your answer. Okay, so first let's just figure out some of the totals here. 54 plus 36 is 90, 25 and 40 is 65, 27 and 18 is 45, and then going across, this is 106, across, 94, and everything will then add to 200. So we're going to look at gender and music style. So let's pick probability of female and the probability of female given techno. So the probability of being female is 106 out of 200, which is 0.53. Probability of female given techno, we look at just at the techno, number of females, that's 54 out of 90, which is 0.6. Since they are not equal, these are not independent. Find the probability of randomly selecting a student being female and liking country music. So this is probability of female and liking country music. So female liking country music is 27 of them out of everybody, which is 200. Okay, and this was an and computation. So 27 divided by 200, 0.135. Find the probability of a randomly selected student being a female or liking country music. So we're going to look for the probability of females plus the probability of liking country music and take away those that might overlap. Because we're looking for people who are female, people who like country music, or possibly both. We just don't want to count them twice, so we're subtracting the overlap. So probability of females was 106 out of 200. We actually calculated that earlier. Probability of liking country looks like it's 45 out of 200. Take away any overlap. So females and country, which was 27 out of 200, which is 124 out of 200 by just subtracting or adding 106.45 and taking away the 27. It gives me 124, and when I divide, I get 0.62, and that's some work with OR. Okay, we got another table. We're looking at females and males and what their favorite pet is, it looks like. So this shows the type and gender of pets for 100 freshmen. Create a Venn diagram. Okay, so here are my two circles for my Venn diagram. Actually, never mind, I'm not going to create a Venn diagram. Okay, let's do the probability of cats. So it looks like we've got 49 out of 100, which is 0.49. Probability of cats and being male. So male cats, that's 10 of them out of 100. That's actually a joint probability because it's a single cell over the total. Probability of not liking dogs. Well, or not having a dog, I should say. Well, let's look at the probability of having a dog. Probability of having a dog is 51 out of 100, or 0.51, which means then the probability of not having a dog would be 1 minus that, which is 0.49. It's actually the same thing as having a cat. Probability of female or dog, you're looking for probability of female plus the probability of dog, take away the probability of both, or the overlap. So probability of being a female is 0.48, that's 48 out of 100, plus dog, 51 out of 100, or 0.51, take away the overlap. So female and dog, that's 9 out of 100, which is 0.9. Altogether, you would end up getting 90, or 0.90, I should say. Okay, probability of just being male, we've got 52 out of 100, or 0.52. Dogs given male, so we're looking at just the male row, and dogs, which is 0.42 out of, actually I just write 42 out of 52. Okay, and then whatever that divides to. So let's see, 32 divided by 52, 0.807 or 808. Now, this conditional probability can be calculated a different way. You can do the probability of dog and male divided by the probability of male. It's always divided by whatever's given. If you look at your table, dog and male, dog male is 42. Just male itself is 52. And that's where those numbers come from. So if you didn't have a two-way table, but you knew those two probabilities, you would just have to know how to divide them. Okay, so let's actually try that for the one right below it. Probability of cat given female. It's the probability of both divided by the probability of whatever's given. So cat and female. Cat, female, so that's 39. Divided by the probability of female, which is 48. 39 divided by 48, 0.8125. And then lastly, the probability of just female looks like it's 0.48. Okay, so we've got males, females, and political party preference. What is the marginal relative frequency of the number of males and females that are Democrats? So we're looking for an answer from the margins. The probability of a male, looks like I have 20 males out of a total of 36 people. Okay, so 0.556. The probability of a female looks like I have 16 total females out of 36. 0.444. So what is the conditional relative frequency of the number of males that are Republicans? So we're looking for the males. So of the number of males, so that's just this row, how many then are Republicans? So 7. So we've got 7 out of 20. Which is 0.35. Alright, so this next one is about a standard deck of cards, and you're pulling a card out without replacement. So that means that you're not putting the card back in the deck. Find the following probabilities. So the probability of taking 2 black cards. Well, half of a standard 52 deck is black cards. So that's 26 out of 52 cards. but then you're pulling out that card, that black card, and you're not putting it back. So if you want to pull another card from the deck and you don't put the card back, that means you now have 51 cards to pull from, not 52. Additionally, because you took a black card out and you didn't put it back, you have less cards to pull from as well. So instead of 26, you have 25. 26 times 25 is 650, divided by 2652 by multiplying across, divide it, we get like 0.245. A spade followed by a club. A spade and a club are each suits in our deck. There are 13 spades and 13 clubs. So if I pull out a spade, that's 13 out of the 52 cards. If I pull out a club, I still have 13 clubs in the deck because I didn't pull one out. However, because I didn't put the original card back, I'm only pulling from 51 cards. So that would be 169 out of 2652, and then whatever that divides to. If I want to pull out two hearts, again, a heart is a suit. So there's 13 hearts in a deck of 52. But if I take one out and don't put it back, I'm now pulling from 12 hearts out of a total of 51 cards. So 13 times 12 is 156. 52 and 51 is 2652. A face card followed by another face card. Okay, so if you have a look at your deck, you have 3 face cards per suit. So that's Jack, Queen, King. And you have 4 suits. That means you have 12 total face cards. 12 out of 52. But if you pull a face card out, don't put it back, you're now pulling from 11 face cards out of a total of now 51 cards. So 121. Or excuse me, 132 out of 2652. Only one card drawn from a standard deck. Find the probability of a queen or a black card. So the probability of pulling a queen plus the probability of getting a black card, take away the probability of both, because you don't want to count them twice. In a deck, you have 4 queens, one of each suit. Half of the cards are black, though, so that's 26 out of 52 cards. Now keep in mind that half of the deck is also black, so that means of those 4 queens, 2 of them are red, 2 of them are black. So I have to subtract the 2 that are black because I already counted them. So 2 out of 52, that gives me 30, take away 2, that's 38 out of 52, and then I would just divide that. Okay, a rural middle school has a population of 900 students. The number of students who are in the musical is 35. The number of students who are members of Junior National Honor Society is 122. If the probability that a student is involved in the musical or Gen HSS is 121 out of 900, what is the probability that a student is involved with the musical and NJSS? Now, they're giving you a probability for an or statement. So I'm going to write that down. Probability of musical or JNHS. That would be equal to the sum of both of them. Take away any overlap. Oops. Now there's 900 students in the school, right? They're telling you 35 of them are in the musical. So 35 out of 900 are in the musical. Those that are in JNHS is 122 out of 900. You don't know how many are in both. It's the and statement, so let's call that X. But you do know that the or is 121 out of 900. So 121 students are overlapping here. So I'll clean this up. This is 121 over 900 is equal to 35 plus 122, which is 157 out of 900. Take away x. When I solve for x, so either add over the x and then subtract 121, x is equal to 36 out of 900, which is 0.18. Okay, at Williams-Weiss, the probability that students are involved in a club is 0.64, and the probability they're involved in a sport is 0.55. The probability that they're involved in both a sport and a club is 0.43. Let C represent involved in a club and S represent the involved in a sport. Find the following. Now, if you're trying to find a conditional, you could write out a whole two-way table, or just know your formulas. Probability of C given S is the probability of both of them divided by whatever's given. So just like so. They gave you the both probability. That's 0.43. They gave you the probability that you're in a sport. That's 0.55. When I divide those, let's see what I get. .782. And that's your probability. Probability of C and S, well, they gave that to me. That's 0.43. What about or? That means club plus the probability of sports, take away any overlap, because you got to figure some of these kids are in both and you don't want to count them twice. So just being in a club is 0.64. Just being in a sport, or not, I shouldn't say just, they're in a club, 0.64. They're in a sport, it's 0.55. They're in both is 0.43. So add them together, subtract, you get 0.76. And that's your probability. All right, one last problem I'll go through. A survey was done to determine that the relationship between gender and subject preference. A total of 56 students was surveyed to determine if they liked math, English, social studies, or science as their favorite subject. The results were then broken down into whether they responded was male or female. Which of the following is closest to the joint relative probability of being a male who likes social studies? So we're looking for male, looking for male liking social studies. So that's 8 of them out of a total of 56. And that's a joint probability. 8 out of 56. 0.142. So that's option 2. Which of the following is a marginal relative frequency of liking math? Marginal means our answer comes from the margins, and that's where this 18 is coming from. So 18 people have said that they like math out of a total of 56. 18 out of 56. There it is at option 4.